Hello everyone, welcome back to the next section of the multimedia system. Today we will be discussing with a new topic, that is graphics and images, video technology and computer based animation. This is the fourth module that we are about to discuss, and this module comprises of the three main concepts. So that's why you can see that graphics and images, it's a chapter in the textbook, and again video technology and also computer based animation. These three chapters are combined together to form a one module, and that module will be discussed in this session. Excuse me. Let us see what are the things that would be covered in this session. When we talk about the graphics and images, we will be discussing about the capturing of graphics and images. So how the images are captured, how the graphics are captured, all the parameters associated with it will be discussed. Next we will move with the computer assisted graphs and image processing. A bit of concept of image processing, how images are observed, what are the different types of processing that are involved in order to have those images or the graphics. And also we discuss about the reconstruction of images. So the different properties are used here, and in the property of reconstructing the images what we have. Third one, and finally we discuss about the graphics and image output options. So what are the things that we have obtained as an images, when we construct, how do we output or how do we display those things. Those things will be discussed in graphics and images. While coming to the video technology, we see about the basic technology of video, that is the moving pictures. We also study about some of the TV standards. So we also look into the digitization of video signal, the importance of video signal and its digitization and uses will also be discussed. Finally, we look into the digital television concept that has been emerging and the latest trend. And finally, when we come to the topic called the computer based animation, we see about the basics of concepts like animation, what is computer based animation, all these things, and we look into the specifications of animations and methods for controlling the animation, how to display the animation and transmission of animation, and finally we look into the virtual reality of the modeling languages, which are very important in order to go with the animation. Now let us start our discussion with the graphics and images. We know that graphics are normally created in graphics applications and internally represented as assembly of objects. This is very important. So when you talk about graphic, these are represented with the graphics application and it is internally represented assembly of objects. So what are those different objects that are combined to form a graphics are? It might be lines, it might be curves, and also it might be circles. When you talk about curves, extended version would be circles. So these are the different objects that are used to frame a graphics. When we talk about the attributes of graphics, it constitutes of these graphic images constitutes of style, width and color. These are the attributes. So we know that how the graphics are done with the help of assembly of the objects. What are those objects? Line, curves and circles, and there are a lot of attributes are associated with that. When you talk about the graphics, what are those attributes? Style, width and color. They define the appearance of a object. Now it's very clear when you talk about the graphic, it is formed of lines, curves and circles. So how do they represent as a graphic is the style, color and the width. So these define how graphics are appearing as an object. When we talk about the graphic, the smallest addressable image of an element is said to be a pixel. Thus we should not forget. What do you mean by a pixel? The smallest addressable element of an image is said to be a pixel. Now the array of the pixels, the array of set of these pixels are said to be the bitmap. This name is very familiar when we talk about the attributes of a multimedia. We have seen the different types of images where we have discussed about this word called bitmap. Then what is bitmap? It's an array or a set of pixels. Now when we talk about the object based editing, it is not possible here because we are totally dealing with the types of graphics and images, but image editing tool exists. So we are not able to define the direct editing of these objects. What are the objects here? That's why I wrote here lines, curves and circle are said to be the objects. I highlight here. So it is not possible to edit these objects. So it is not that we can take a line and introduce one more circle. It is different. So it is not possible, but the image editing tool exists so that you can retouch or enhance or modify the quality of the bitmap images. So this we should make the concept clear. So editing is not possible, but editing tools are available so that we can modify. We cannot edit the objects itself, but we can retouch the object or fine tune these objects with respect to an image. Then what is the drawback? The most of the time when we talk about the image, we said JPEG is the best that compared to the bitmap also. Then what is the drawback of bitmap image? The main drawback is it needs more storage capacity than the graphics. This is the drawback of bitmap. That too than the graphics. Just an image consumes more space than the graphic images. Why? There is an advantage. When we say about this is the drawback, because of this drawback there is one more advantage. What is that? You know that whenever we wanted to have an image, we need to do a pre-processing activity of an image. Whereas here the advantage is that bitmap images no processing is necessary for those images because they display them directly. Unlike graphics, the abstract definition must be processed first to produce a bitmap, whereas here since there is no compression, there is no other modification, there is no other extra activity done on these images, they store lot of storage space and no pre-processing activity is required, it can be directly accessed. This is the advantage of bitmap. So I always tell you, whenever we talk about an advantage, there would be a disadvantage. When we talk about a disadvantage, there would be an alternative advantage. So what is the disadvantage of bitmap? It consumes lot of storage space when compared to the graphics, but what is advantage? It does not require any kind of pre-processing. It can be directly used to display the images. This was the basics or introduction with respect to the graphics. Next, we will move into the next concept, that is capturing real world images. Now the name itself suggests now we are dealing with how to capture the real world images. When we talk about the real world images, always a picture is captured in the 2D format, that is two-dimensional. In any of the real world scenario, we capture the image in a 2D, that is a real world scene that represent the momentary event. Now when we want to represent this momentary event, means if a picture or a motion that is in a momentary, we need to represent that in also three-dimensional way. When we talk about the object will be always in two dimension, that is x and y axis. But when we want to represent an image or a picture which is momentary, means which is an action, which is a motion picture, there would be one more vector or one more parameter that is coming into existence, that is called the yz. We call it as third dimensional. So these momentary images, if we want to represent, it should be considered with respect to the three-dimensional because of the momentary event. Now let us look into a diagram which shows that the camera obscura, OBSCURA, we'll see what is that obscura. When we consider camera obscura model of an image capturing system with the focal length, when we talk about the anything capturing, we might see a camera where we do a small variation with respect to focal length. So how the distance is there, we move those things lengths and we slightly adjust. That is called the focal length. That is represented by always the letter F, where the spatial Cartesian world coordinates. When you talk about Cartesian, what is the free space Cartesian? So when you talk about Cartesian world coordinates, always it would be 3, W1, W2 and W3. Why is this 3 Cartesian coordinates are used? It is simple. We are supposed to represent the 2D object with respect to momentary event, that is 3D. That's why we have 3 coordinates, that is 1, the 2 and the 3. So that's why we represent as W1, W2 and W3. We call it as Cartesian coordinates. So this is called a Cartesian coordinate system. So camera obscura means we see how the camera is placed in a position where we can have the focal length change and how to derive the object or generate the object. These points are mapped onto the coordinates of an image level with respect to W. When I talk about the W, it consists of R and S. 2 parameters, that is R and S, called the projection. Now when we talk about this, we will be able to derive with the focal length and the Cartesian coordinates and the image level coordinates by applying the central projection equation. How does the central projection equation look like? So central projection equation is given by R is equal to F. What is F? We know that F is the focal length. F into Cartesian coordinate of first with respect to the third dimension. One part, that is x and y coordination, and then S with respect to the focal length into second Cartesian coordinate with the third direction, the third aspect, that is a vector. So this is called the central projection equation that has been already given. So using this we need to capture the image, so that is from the outside world onto a frame. So how we do that, we will see that. So I wanted to recall what is camera obscura. When you talk about the camera obscura, it's a darkened room. So it's a pitch dark room with a small hole or a lens at one side through which the image is projected on the wall on the opposite hole. Means here the image is there, we have a small hole or a lens through which the object in the reel or a box is been projected outside the wall. When we want to do this projection, we need to do it in a real time parameter. So when you do up a real time, it is always I represented the 2D has to be projected in the 3 dimension. That's why we consider the third coordination vector with respect to the Cartesian coordinate. Let us look into the diagram so that the explanation becomes easy. I'll write the diagram. Now look at this. This triangle is an object, image, present in the frame. What is the main intention? I want this object to be displayed through the lens on the opposite side of the wall or a screen. How to do that? Now it is totally with respect to 2 dimension. R and a S coordinate. Okay, just 2 coordinate, R and a S, because it's a plane. So we know that every plane that is written on a frame or an object or a paper is 2D images. So we need to convert these 2D images into a 3rd dimensional representation. What we do? As written, 4 quadrants with the things. Now look at this. We have the vectors. Now what are we supposed to do? We are supposed to generate the image into different. How do we do this? Now the representation of this image can also be projected with the line and displayed. I will take up in a bigger position image so that the explanation could be made very clear. Okay. Now look at this, the 3-dimensional concepts with respect to the 3 points. All these things converge here. Now the image, the line, the center one, so which obviously is projected in a bigger fashion. What are we doing here? So this length is referred to as the F, focal length. So the length at which we produce the distance of the object from the origin of the hole or a lens towards the projection is said to be the focal length. So this is how we generate or create an image or produce an image through a darkened room in a small hole or a lens on the other side, through which the image is projected on the opposite hole or a wall through which the images are produced. So when we talk an image with respect to a capturing device, how do we capture? We capture these images with a CCD scanner, or you know that CC camera, or a still image or a frame grabber, which grabs the images from lot of frames. You know that a sequence of images is said to be a frame. So we can capture a particular or grab an image through the sequence of frames of a moving images. What we do next? Next, we convert the brightness signal into electrical signals. This is important. What happens here? During the process of generation, so brightness signal will be there. That is convert into electrical signal. These both are signals. We convert the brightness signal into electrical signals. In contrast to the conventional TV standards, the use of line structure system, the line direction of output signal that capturing devices generate normally continues in a row direction like this, but the discrete and analogs are in a column direction. So we might have seen in the raster and other kind of displays we have discussed, it would be like this or like this. That is how you can see very clearly image being produced. You can see sometimes the half image is produced, later a bit of millisecond the next sequence of image can be produced. This is how the images are generated by converting into the brightness signal into electrical signals. Now when we concentrate on the steps with respect to these items, the whole concept can be described in two main steps. What are those? When you talk about the first step is processing the real world picture into sample and digitize these signals. First one, process. The real world images. So why do we need to process? Because when we talk about the image and everything, this would be in two dimension. We need to convert into momentary third dimensional objects when we produce, and this processing is needed in order to sample these images to form the brightness signal into electrical signal. Indirectly, what we are doing? We are digitizing. It is said to be the first step of any image capturing. Then what is the second step? During the second step, normally involves quantization. Sorry, we know that what is quantization. We have seen the word quantization from the module 1, and we have discussed different types of quantization in both audio technology and video technology. So here in this process of stage 2, we do quantization. So when we talk about the quantization, it is done to achieve an aggregation of colors. So we combine, because we have digital signals where different brightness and colors are there, we need to aggregate. When you talk about aggregate, it is combining of colors. So here we aggregate the color regions. There are different regions. So what we might say that, so what about the gray? Yes, gray also different color regions. When we talk about color region, it would be from white to black. So there would be different shades. So we aggregate these different color regions together. So this is called quantization. Why it is done? It is done in order to reduce the different number of colors depending upon the hardware used to output the images. So different range of colors would be there. We identify those different color ranges and we aggregate the similar color or a group of color ranges. So these are the two main steps that we would be consider while the capturing of a real world images. Then when we talk about the displaying option, so video technology normally works with 8-bit PCM. We know that. That is pulse code modulation, and with respect to a quantization, we do a 8-bit PCM quantization, which means we can represent into 2 to the power of 8, that is 256 different colors. It might be a different colors, or even it might be a gray level. Okay, now I think the things are very clear. It can be used with respect to 256 different colors or 256 different gray levels. That's why we need to aggregate the different color regions, okay, as per the pixel. Now when we talk about the results, it is obviously, since we are using 3-dimensional, it is 2 put to the power of 8 into 2 to the power of 8 into 2 to the power of 8. When we do this kind of calculation, we would be able to get an approximately 16 million different colors. That's why we are having the Cartesian coordination of representation. That's why I wrote here in the before W1, W2, W3. So in the realistic 3-dimensional. So this is how we are able to achieve 16 million colors that are associated with respect to the production or capturing of image. Next, the digitization process is represented by a matrix which is composed of rows and columns to accommodate the numerical values. So now we know that it needs to be digitized. So this process is represented by the matrix. So we have discussed the representation of matrix as 8 cross 8. During the process of JPEG and MPEG picture compression, we have used the 8 cross 8 matrix, and we have represented that concept can be recalled here. Each matrix entry corresponds to the brightness value, means the values that is represented here in the matrix is representing the brightness. So we know that this values of representation of digitization is done on a matrix. So what does that value represent? Each value, either it might be 0 or 1. It is representing the brightness that is associated at that position of the pixel. So this, we know that pixel, that's why I represented the importance of pixel. So specifying a 2-dimensional matrix, then we represent the intensity by I of row comma column. Means intensity of the particular, if I want to represent a particular value here, I represent intensity of row position and column position. That gives the value at that location. Each pixel has a numerical value that can be a number or a bit of values. That each code of pixel is also called amplitude or depth of the pixel. This is also referred as amplitude or depth. So amplitude or depth is referred to as the brightness value. This is about the capturing of real world images. So when we talk about this, the numerical value that we use in the matrix may represent either black or a white color. So I'll wrap this and continue our discussion. So I told you the matrix representation would be represented in binary value, that is 1 or 0 representation. Only these two combination. So when we talk about this, black is either represented always by the value 0. And 1 is represented by the value white. So this is how the amplitude or the intensity value or the brightness value is represented in the matrix. So when we talk about the numerical value of a gray, so there might be a different shades in the gray level from the white to a bit darken and finally we reach the black color. So there is a lot of gray levels in between the starting white and the ending black color. So these numeric gray levels range from 0 to FF. So 0 means totally a pitch black. When we represent FF, it is complete white. So this combination extends the value representation. This kind of rectangular matrix is normally used to represent the images. The pixel of an image is equally distributed in the matrix. Okay, it might be 0 or a 1, it combination, it are equally represent between the matrix dots, and it is obviously measured as the original picture quality. So these values that is representing in between, look at this one somewhere here, all these things, these are represented by the matrix dot that represents the value. It is also determines the degree of detailing the image resolution. So how detailed we can go into the image resolution. These are the concepts that we need to consider when we talk about the digitization or capturing the real world images. When we take up digital images are normally very large. We have seen how is the digitization, but now after the talking about the digital images, these digital images are very large in size. If you want to sample and quantize a TV standard picture, it should be feasible with respect to 525 lines. This is about the TV standards, general standards of a television. We need to digitize the sample and quantize as per the TV standards of a TV picture, that is 525 lines by the use of VGA. When you talk about VGA, it is video graphics array. These captured images would support the 525 lines. This line images or this type of images specifies the result of a matrix containing 3,07,200. 3,07,200 8-bit values. So much big 8-bit numbers are used in order to produce images in the real world. This is about the concept of capturing the real world images. So I think how we do the capture it with respect to 3 coordinates, we need to have the 2 main steps. One is the processing of a real world image itself in order to digitize. So digitize is done in order to aggregate the colors. So all the aspects of matrix representation is done, and finally those images are represented with the TV standards with the 522 lines of VGA compatibility. This was about the capturing of real world images. Next, we look into one of the interesting topics, that is image formats. During the module 1 session, we have just glanced the various types of image format that are available with respect to multimedia concept. Now we will be discussing those image formats in detail. When I talk about the literature, It describes many different image formats, and it also distinguishes normally between the image capturing and the image storage formats. When we talk about the formats of image, these images are mainly categorized or distinguishable between the two main components. One is the image capturing and second one is image storage. So these are the two main entities that has given rise to the different types of image formats. So image formats, in other words we can say image formats can be mainly classified based on these two parameters, how image are captured and how image are stored or represented on the secondary storage device. So which has the following set of 8 important image formats. So what are those? We will look into it one by one. When we talk about image formats, the first concept that we need to know is image capturing format itself. The second one goes like this, that is image storage formats. The third one is a well-known concept, that is PostScript. The fourth one is the GIF, that is graphical interchange format. In short, it is represented as GIF. You might be very familiar with that. So GIF images, you might be seeing GIF images, GIF images. We will see that one by one. And next, the TIFF images, that is tagged image file format. We call it as TIFF. The sixth one is called X11 bitmap and X11 pixmap. So these are the two combination where we represent it as XBM and XPM. In short. Next, seventh one is your portable bitmap plus. It is represented as PBM, or sometimes it is also referred to as PBM plus. I will write it as here, plus also. And finally, the eighth, the important, that is general bitmap image itself. It is referred as BMP. So these are the main important image formats that are associated when we talk about the graphics and images. The first is the image capturing format that need to concentrate. Second one in association with the image storage format, the PostScripts, the GIF files, the TIFF files, that is the tagged image file formats, X11 and X11, big PIX map, portable bitmap plus, and just our ordinary bitmap plus. We will go into this one by one. So what is this image capturing format? When we talk about the image capturing, the format of an image is defined by two parameters. One, the spatial resolution, and second one is color encoding. So these are the two important parameters that we consider when we talk about the image format. One is the spatial resolution, the resolution with respect to the surrounding, and also the different types of encoding is there, what kind of color encoding is done. It is measured in bits per pixel that we have seen it, and the value of both parameters defined on the hardware and the software that is used for the input and the output of images. That is called the image capturing format. So when we talk about the second one, that is image storage format, we know that to store an image, the image is represented in 2D matrix in which the value corresponds to the data associated with one image per pixel. So when we talk about the image representation, we always need to consider with respect to the third dimension. So in bitmap, there are value of binary numbers in which the color images and the values can also be represented as one of the following values. What are those? The three numbers that normally specify the intensity are, when we talk about the storage, the first one is the red, green, or a blue component. The three numbers represent the reference to a table containing, it might be a red, green, or blue with respect to intensities. And third one, that single number that works as a reference to the table that contain the color triples. So different combinations, and its combination of triple colors is been represented in a table. And finally, it also might be an index pointing to another set of data structure which represents the colors. So now we have seen the two main formats of image. So these are the things I had wished to discuss in this session. Thank you very much.